The following presentation should discuss energy in a practical context, our current methods of obtaining it, and the impacts thereof. To begin, we must start at the most basic principle underlying this problem. Put at its simplest, according to the first law of thermodynamics, energy can neither be created nor destroyed. This basic principle effectively rules out all free energy or over-unity claims. These typically take the form of a machine that seems to gain energy from nowhere. This simply can't happen. It's a fundamental property of the universe. Given that we cannot simply obtain energy from nothing, we must then source it by other means. Most energy on Earth derives from solar and by extension nuclear, as the sun radiates the heat generated as hydrogen is fused within. As you can see, tritium and deuterium, both isotopes of hydrogen, come together to form the larger helium nucleus and a neutron. When this occurs, vast amounts of energy is released. The stupendously strong gravity and high temperatures allow the sun to sustain this nuclear reaction. While this source of energy won't last forever, the sun represents an effectively everlasting source of energy. Fuels such as diesel, petrol, or coal, used for vehicles as well as electricity generation in the home, ultimately come from the decayed remains of ancient plants, which themselves required the sun to grow. Since these fuels are usually hydrocarbons, that is, substances containing both carbon and hydrogen, the plants must have obtained both of these from the earth or the atmosphere, and in a very abstract sense, combined them. Water, or H2O, was taken in by the roots from the damp ground after rainfall. It provided the necessary hydrogen. CO2, now well known as a prominent greenhouse gas, is taken in by the plant from the air. The reason a plant requires the input of power in the form of sunlight is that both carbon dioxide and water are exceptionally stable compounds. Put simply, they really want to stay in the form they are. Hence, through the addition of sunlight and processing by way of photosynthesis, which is outside the scope of this video, fuels of many kinds can be created, be they liquid, solid, gaseous, or perhaps most importantly, edible. Note that the fuels mentioned will burn using oxygen in the air to produce carbon dioxide and water, which can then of course feed back through the system to very slowly be recreated as new fuels. This idea of the waste products feeding back through the system to be reprocessed using energy is a core concept of sustainability. An important additional benefit of this strategy is that every substance released into the environment gets absorbed and brought back into the cycle. This results in very little pollution. From all of this, it is obvious that improving our efficiency of drawing power from the sun could bring numerous benefits. For example, photosynthesis peaks at about 10% efficiency, whereas a solar panel can easily double and may one day quadruple that number. Large forests are essential, however, as they effectively trap CO2, preventing its warming effect on the atmosphere. While techniques are being developed to convert CO2 to fuel directly, with the advent of modern energy storage technologies, fuels are very slowly becoming unnecessary in many applications, such as transport or lighting. It follows that the improvements in efficiency made by using alternative methods of energy harvesting, in addition to more woodland, could have the combined effect of repairing damage done to the atmosphere, as well as a greater capacity to sustain comfortable human life. These improvements in efficiency come in a myriad of forms, from all branches of science and mathematics. The development of battery technology, biofuels, more efficient manufacturing, less environmentally unsound plastics, better processing of waste, and the analytical techniques that allowed us to predict these encroaching problems in the first place are but a selection of what chemistry has been able to contribute thus far. So to conclude, it is hoped that this short animation has helped give a brief primer on the extremely broad and expansive topic of sustainability. Chemistry is but one part of the solution. However, given the challenging nature of problems under the heading of sustainability, such as climate change, seawater pollution, and deforestation, every new development within this space is important in combating the problem as a whole. Thank you very much for watching. Goodbye.